Thank you, Diego. 1 million components. I don't know if that joke should follow being a McDonald's joke or a 1 million components joke. It's massively impressive, though. Okay, so my name is Justin. Some of you know me, some of you don't. I've been on the Polymer team for quite a while, working on things like tools and lit-HTML. And tonight, I want to talk to you all about styling and theming web components. All about it in 20 minutes. It's a very vast topic, and it's vast and important. You know, it's critically important to everybody who writes web components and who uses web components. And it touches on some of the key reasons why web components were created in the first place, and some of the core features that web components are built on, like Shadow DOM. And one of the reasons why this topic is so big is because there's a lot of dimensions to it. And sometimes these aren't always specified or made clear while people are talking about this. So I wanted to make sure that I talked about how I see the different dimensions of styling so that we know what we're talking about when we talk about why each feature is useful. So I kind of see it as these three dimensions here. We have defining components versus using them. We have styling versus theming. And we have the platform features versus things that you can do in userland. And to go into each of these a little bit here, when I talk about defining versus using, anytime that you make a web component, you typically need to style that web component, the internals of it, to give it some appearance. And so that's going to be the blue circle here. This is your component, and that's its internal styles. But every component is also used, and it's used in some environment. And throughout the deck here, I'm going to use this green dotted line. Hopefully everybody can see this. To kind of represent like a scope or the environment that a component is used in. So when we talk about styling, we want to talk about each feature with respect to whether or not you're using it to define the component or whether or not you're using it to customize the component. Likewise, we have this dimension styling versus theming. So when you use a component inside of a page, you have an inherent scope in that page. That's going to be this scope here. And you also have, let's see. Oh, and when we talk about styling, what I mean is that you directly style the elements that are in your scope, the elements that you're actually using, not the elements that those elements are using to build themselves with, right? So this would be direct styling. And when I talk about theming, what I mean is styling that kind of cuts across large swaths of elements, that cuts across the entire page, and importantly, across different scopes. And then finally, platform versus userland. So on the platform, we have native features, and these features often require native implementations because they might have features that you can't, say, polyfill. So here we have an example of using a new syntax, : part, which allows you to select a subcomponent inside of another component. And this is new native CSS syntax. So this has to be implemented natively in the platform. But if you wanted to do something somewhat similarly in function, but not using native CSS, if you wanted to do this in JavaScript, you could conceivably write a JavaScript library that lets components cooperate and share styles and themes across components via some kind of JavaScript registry. So this is the difference between native and userland here. Okay, so I'm going to get into a bunch of techniques that you can use to style and theme components. Before that, I want to do a very quick overview of Shadow DOM and why these different techniques are necessary. So first of all, Shadow DOM gives us, with respect to styling, it gives us scopes and bounds. So a scope is really just an area where the styling applies to, and it only applies to that one isolated area. So here we have a scope for the myParent element here. And this tree right here is not an HTML tree. This is a component tree. So every component, lower in the tree is just a component that component above it is using. So here, this myParent scope contains only the two myElement children inside of it, and not the other elements. This child here, this myElement child, has its own scope, and that's going to contain its direct children. And so what Shadow DOM gives you is it gives you bounds. So let's say this element right here wanted to style the myChildren element that it's using. They want it to style them pink. So it's going to write some selector like myElement and make it background pink, right? And without Shadow DOM, this will make all the elements in the page pink, and that's not what we want. So the first thing Shadow DOM gives you is an upper bound. And what the upper bound means is that your styles don't leak out above you into the page to your parents and then down into your cousins. So that lets us target the right elements a little bit more here. And the second thing it gives you is a lower bound. And the lower bound means that you're not going to style the components that your components are using to implement themselves. And so now we have the right scope here for our styles. And this is the thing that is critically important about Shadow DOM. This is what lets teams scale styling across hundreds to thousands of components and lots of different teams and potentially thousands of developers, and know that if they put a style in their Shadow DOM that says like style a div a certain way, which would, in yesterday's world, that would be totally irresponsible. Now it's actually good because it's a very simple selector. You can reason about it when you look at your shadow root and your styles. You know it'll perform well, and it's not going to pollute the entire page. So Shadow DOM gives us this really critical functionality for being able to build and use components at scale. All right, so encapsulation, it's awesome, right? Basically, yes, until we get to a couple of problems, one of which I like to call the Bootstrap problem. So when we unveiled web components in Shadow DOM, one of the first things people hit is, hey, I want to use Bootstrap to style all my components across the page. I'm also using Shadow DOM, and it's not working. And the reason why is because Bootstrap tries to reach into every single component across the entire page and do stuff to it, right? And that's just not how Shadow DOM works. So Bootstrap is a theming problem, and Shadow DOM, needed some extra ability to support theming. So that led to some frustration, encapsulation, boo. So, this real story somewhere in the middle. What's really happening here is that with Shadow DOM encapsulation, what you have is some internal structure to your component. There's some internal piece of that component that you're using to implement it that you also want to allow to be styled and customized. And so encapsulation gives you this yellow circle here, this encapsulation boundary. And Shadow DOM makes that fairly strict. And so what we really want to do is we want to pierce that boundary, and we want to expose some of that internal structure into the public interface. And so that's what we're going to look at with the techniques here, is how to do that, how to take the strict encapsulation from Shadow DOM and relax it a little bit. And so that means that encapsulation is it's good, but you have to think about it a little bit, and you have to design around it. So the techniques we're going to look at, we are going to, sorry, the preview is very small here, so let me adjust this. All right. We are going to look at a number of different things here. One is styling the element itself, your host. Another is styling children. We're going to look at how CSS properties inherit through Shadow DOM, shadow parts, custom pseudo classes, theming, which is a proposal coming up, and then some userland library techniques. And we're going to do this all in the remaining part of my 20 minutes. So first, let's look at defining components. So we're going to look at styling a shadow root from the inside. This will be a common knowledge for some of you, but first I want to cover how plain selectors work. So if you have a selector in a shadow root, it only selects the elements in that shadow root, nothing else. They don't apply to outer or inner scopes. So here we have an example. And by the way, I'll show how this works a little bit later, but I'm using lit element, which lets you define your styles as this static styles property here. All you need to know is that it applies these styles to the shadow root. So here we're going to color a div. Again, usually irresponsible in the shadow root. It's awesome. And that's just going to make this div down below that we have in our template red. Then we have the host selector. So the host selector selects the component itself. And one way to think about this is that this is relaxing encapsulation a little bit, because the host element lives right at that boundary between the outer and the inner scope. It's both kind of present in the inner scope and selectable by the host selector, and selectable from the outside. And one way to think about the host selector is that it defines the default styles. These styles are very easily overridable by users because they just select your element and set new properties, and they override these styles. So this is very similar to the styles that built-in elements would have in the browser. The next interesting selector here is the host selector with the parentheses, the function form. So this styles the host element conditionally. And inside of the parentheses here goes another simple selector that matches against the host. So here in this example, we have two host selectors. One is the normal host selector I showed on the last slide, and the next one is going to select against the host only when it has this cool attribute. So you can see we have a sub-selector in there, which is the attribute selector. And so this means that whenever you add the cool attribute to the component, its background is going to be mint cream. All right, next we have the slotted selector. Slotted is how you select the children of a web component that have been slotted into a Shadow DOM slot element. Another way to think about this is that it is relaxing the Shadow DOM encapsulation boundary again, because here you have styles inside of the shadow root that are kind of reaching out up into the scope that's using it to style the children there. And so the way this works is you use : slotted in the CSS here, and you give it another selector, which will select against the direct top-level children only, and then you can style them. And so in the example HTML down here below, this will select the top paragraph there and make it red, but it will not select the nested paragraph inside that div and make that red. Okay, so those are the basic things we have available for kind of styling the component itself as you write it. The biggest thing to know is that you can write regular selectors that will only select inside that shadow root. Then we have using a component. So we're going to talk about styling it from the outside. So first, let's look at plain selectors again. Now you can just use the tag name for your custom element and select it. And again, this is going to override the default properties that you've set with a host selector inside of that component. So this overrides the default styling. Custom elements at this point are just elements like any other. So there's really nothing special going on here. And the important thing that Shadow DOM gives us is that we cannot accidentally style the shadow root internals. Except for one exception. And that's inheriting properties. So a lot of CSS properties like font face and color naturally inherit down the tree. And inheritable properties do inherit through shadow roots. And this is actually quite useful, because you can imagine how hard it would be to deal with if you had to explicitly theme every element in your page just because you wanted to set the font. So setting font and color will go through the page, and you'll get some basic consistency with styles. So here we're going to set the color to aquamarine, and this is actually going to work even if we didn't make any special carve-out for the color attribute here. So next, we have custom properties. Custom properties are what we lean on currently, like very heavily, to do styling and theming for web components. There's two things that really work well for custom properties here. One is that you can use them in a number of different places. So you can use them like a variable and set their value to, set a color value to blue and use it both as a border and a background, right? And the other is that all custom properties inherit. So you can style the internals of a custom element if it uses a particular custom property and you know about that and use it. So you can define a custom public styling interface with these, right? So on the inside of your component, what you do is you don't really declare that you're using a custom property. You just go ahead and use it. And you use it by using this var function, where you give it a custom property name to use as the first argument. And the second argument is going to be a fallback in case it's not specified. And then outside of the element, you just use that custom property as you would any other, and that's going to style that element. And what's interesting here is because it inherits, it's going to inherit through multiple shadow roots. So you can actually do deep theming this way. But that's also a little bit dangerous because we're just using these string names for the custom property names. They can be anything. You could easily have collisions. So we recommend that people choose the names wisely, like prefix them by the element name or by some kind of element collection name. Okay, so that was what we have today. And now I'm going to talk about what we have kind of today or in the very near future on other browsers than Chrome. So we're going to start with shadow parts. Shadow parts are also known as custom pseudo elements. So if you know our friend, the input element, and you have pseudo elements like : placeholder, this lets you define pseudo elements like that for your own web components. So you do this with the part attribute. So inside of your shadow root, you put a part attribute on a component that you want to be stylable from the outside. So in this example, this might be a video player or an audio player. I'm going to call this div the thumb, and you just say part equals thumb. And that's all you need to do to make that accessible from the outside. And then on the outside, you use this syntax here where you go a selector and then : part, and then the part name inside of it. It's kind of like a class name. And so that lets you select that element and then set any property you want on the element. And parts can also have multiple names similar to classes. So this is great. This lets us style components, the components we use directly. Part does not inherit deeply, though. So if you wanted to, say, set the video thumb color for every component in your page, and they were nested inside of shadow roots, you couldn't just set this at the top of your page and have that work. There's another proposal coming up I'll talk about for that. Another interesting part about shadow parts is what we call forwarding. Okay, so I just said they're only stylable from the direct scope that contains them. So if you do want to style a part from somewhere further up the tree, let's say you're writing a compound component and you want to allow for, like in a dialogue, you have an OK button. You want the user of the dialogue to be able to style the OK button's internal part that it has for its like icon or something like that. You have to forward that part out because it's not reachable through several shadow roots. So the way you do that is by forwarding a part with the export parts attribute. So here we have some component that's going to be using the my element we had on the previous slide, and it's going to say I want to export its thumb part. And that means that this component is now also going to have a thumb part. And then you can style it with this other element selector here, and we're going to select the thumb, and that also styles that there. So by forwarding parts up the tree, you can take parts that are declared deeply in your application and kind of gather them together and forward them all the way up the tree. That might be a little bit cumbersome, though. So we'll get to the solution for that in just a second. So yeah, next is a proposal that has just been made and discussed at TPAC. This is a kind of analog to custom pseudo elements, and this is custom pseudo classes. So if you think about a checkbox or any element that has mouse hover over, there's a number of different states that elements can have in your application. So elements might have the hover state represented by :hover pseudo class, or the check state represented by :checked. And so this is very useful. You might want to add states to your own elements. And that state is internal. Right now, the only way that you can kind of express that your element has a stylable state is to reflect an attribute for it. And that makes this state kind of public and mutable by the users of your element. And you don't really want to do that. So what we have here is this API that is part of a new element internals API, which has been added for form participation and accessibility. And so we're going to add what we call states to that. So the way element internals work is we have this API called attach internals, and that gives you this private object that you can do stuff to that no one else outside your component can talk to. And it's just going to have this state object on it. It's going to work a little bit like a class list, and you're going to be able to toggle these states on your element. Once you do that outside the element, you're going to be able to style it with this :state pseudo selector here. So you do :state, and then you provide it with a state name. It's very similar to, :hover, something like that, and then you can style that state of the element conditionally. These happen to go very nicely along with parts. So you might have parts inside of a complex component that might be active, say, and so you'll be able to select the part and the condition, the state that you want it in before you style it. So here we're going to select our video player thumb, but only when it's playing, and we're going to make it red. So this is a proposal, but it just got a very warm welcome here at TPAC last week in Japan, and so I think this will be moving forward pretty fast. Okay, so that's styling, both from a defining and a using point of view. Next, let's take a look at theming techniques. So just refresher, theming is the same as styling, except for it's deep styling. Themes will cross many different shadow boundaries. And ideally, themes are tree-based, meaning that they're not global, right? You might have, say, a panel in your application that you want to be a certain color theme or maybe a different density than the rest of your application. So you want to be able to set your theme at a certain point in your DOM tree, have that cascade to just that DOM tree, and not pollute the rest of the page. So the first technique for theming is one we already talked about, custom properties. It's the only really deep styling mechanism that we have available today. It actually works quite well for design systems. So if you look at the material design assets that we work with, we'll have lots of places where we define CSS custom variables, and you can put these at the top of the page to define your material design theme, and they will style the whole page. Or you could put them at just one part of the page to style that isolated part. And so you'll typically see these as long custom property names where you'll have properties that are sometimes very similar to the built-in CSS properties. They might be background color, base color, things like that. But you might have more abstract colors in here, primary color, things like that. And then these will be routed by the components themselves to the actual native CSS properties that they need to style. So this is very nice. It's very powerful. It does get a little bit cumbersome in that you have to specify all these properties individually, as opposed to just being able to select an element somewhere on the page. So that brings us to : theme. So this is very much like : part that I discussed, except for it works deeply. This was originally part of the shadow parts specification, but there was some disagreement about how it should work and whether or not part should by default be accessible by the theme selector. So it was removed from Shadow Parts v1 specification, and we think we have a new proposal for it upcoming. But this is my best guess is what it is going to look like, is that just like : part, you're going to have an attribute. It'll just be called theme, possibly. And then we'll have a : theme selector, and it will basically work the same as : part, except for it'll work deeply across shadow roots. This is just a proposal subject to change. We're not exactly sure what it's going to look like, but hopefully something like this. So this is finally going to give us that ability to have our encapsulation and eat it too, to be able to style deeply across all the shadow root boundaries. So finally here, I want to talk about user-land theming. Because Shadow DOM has, put a lot of restrictions on how you can do styling. When we like that, it's great. When we don't, what do we do? So if you can't wait for, say, native features to come along to help you, one thing you can do is you can have elements cooperate to provide and consume themes across your application via a JavaScript API. So this is not a real library at all. This little snippet of JavaScript up here at the top, themes.add, my element, and some CSS. I just made this up. But we do have libraries out there that have added APIs like this. Vaadin has a themable mix-in that they use for their elements that allows elements to cooperate. But the idea is simple and it's fairly common. It's just that you have some place globally in JavaScript that you can register some styles and key them however you want by some kind of name or by some element name or something. And then you have your elements just look up the styles. So once you define the style here in the registry, you might have an element say, okay, I'm going to get styles for the my element tag name here. And after I attach my Shadow DOM, I'm going to adopt the style sheets. And I apologize, I reordered some slides here, and so I'm going to talk about the adopted style sheets here in a sec. But the idea here is basically you can do cooperation via JavaScript to get around some of the restrictions of Shadow DOM if you need to. And so this might be very, very useful to do inside of, say, a closed design system or a corporate environment where you control both ends of the components like this. Okay, so to wrap up, here's how you can kind of relax or escape from style encapsulation. We have host styling, styling children, inherited properties, and shadow parts. These are all kind of the current state of the world. And then hopefully we're going to get custom pseudo classes and : theme very soon. I did want to talk about a related topic here that's kind of going to tie things together, which is loading styles. So we can write a lot of different CSS and selectors, but one of the questions that comes up a lot is how do I get those styles into the browser along with my component? So we have a number of different options. Going back to kind of classic techniques, the first one is putting style tags in your shadow root. So any style tag inside of your shadow root is going to apply only to that shadow root. And so if you have, here I have a very vanilla element. This doesn't extend lit element. This just is going to create a shadow root imperatively in the constructor, and it's going to inner HTML a style tag. And so this thing selects the div and it colors it, and this is scoped and it works and it's fine. And this might seem wasteful because we're creating a style tag in every single shadow root for every instance of this component, but most browsers deduplicate style tags that are identical. They cache based on their text content, and so this is actually going to perform quite well. So this is our kind of bread and butter technique, or has been for the past few years. Another option we have is you can put a link tag instead of a shadow root. So this pulls in an external style sheet. A couple of caveats here, and I actually don't recommend this technique. I put it here for completeness, is that it does not block rendering. Link tags are always asynchronous. So this has the potential to create a flash of unstyled content. Another catch is that the href attribute is relative to the page, not the component. So you might use the JavaScript module system to load the definition of a component that's somewhere in your node modules folder, and it wants to load its own styles. It's going to have to kind of infer where it is in your URL space to be able to load the styles, and sometimes that's very difficult to do. We hope to solve that with some upcoming standards too. But generally, this is not a great idea, so let me move on. So the new thing that is awesome is Constructible Stylesheets. So Constructible Stylesheets lets you just new up a style sheet in JavaScript and then set its text. And then from there, you can attach it to multiple shadow roots throughout your application. So the awesome thing here is that you can create the styles in JavaScript. So we do this in lit element. The styles come in the JavaScript module. We create a new style sheet object, and then every time you create a component, we just attach it. And so this means you're going to be referring to the same style sheet object from every component. And this is going to be the most efficient way that you can share styles across components. So here we have a whole bunch of components of the same class, these my elements. They all have a reference to one shared style sheet. And this is great both for performance and because if you want to do interesting techniques like dynamically update the styles on your page, you can just modify this one style sheet here and have it affect all the components on your page. So like I mentioned, we use this in lit element. So we define your styles with your component as the static property in the class definition here. We don't polyfill constructible style sheets, but we use them if they're there. And if not, we have a fallback technique where we inject style tags into the shadow root. And so this gives you basically the best performance possible on Chrome and then works in the other browsers as well. Another thing that you can do with this, which is interesting, is it shares styles across component definitions. So what you can do is import some styles from another module, and then you can use them in your styles definition here. So if you have some common styles that might be used for theming a bunch of components, this is one very easy way to do that. Okay, so CSS constructible style sheets are awesome because they let you share all these references, but it was a JavaScript API. You do have to kind of new it up, call replace sync with some text that you got from somewhere, presumably also JavaScript. And it turns out people really want to load their CSS from CSS files. So wouldn't it be great if instead of this replace sync kind of stuff here to get a style object, you could just import it? And so that's what CSS Modules gives you. This is a new proposal. You can import CSS into JavaScript. Yay. It gives you a CSS style sheet object just like you would create by newing a CSS style sheet. One nice thing about it is being part of the module graph in JavaScript, it can be loaded and parsed off the main thread. And this is being implemented right now actually for Chromium by Microsoft as part of the Edge partnership we have now. And this is great for a bunch of things. It's great for tooling because now you can use Sass and PostCSS to generate your CSS, and you just have an easy way to import it. And it's great for sharing styles across other frameworks and tools that might not be using Shadow DOM. Okay, and if we put it all together, what do we have? So this is in the very near future, I hope, what styling and theming is going to look like. We're going to have encapsulation, which is great for styling at scale. But we're also going to have our styleability when we use web components and themability, and we're going to have a sane, performant way of loading all this into the browser. So we're going to load styles with CSS modules. We're going to apply them with adopted style sheets. We're going to style our components with parts and custom properties. We're going to style different states they're in with the : state selector. And then we're going to theme deeply across the page with custom properties and something very similar to, if not exactly, : theme. So that was my whirlwind tour of styling. I hope it was informative and useful, and thank you very much. All right.